Hello everyone. Okay, in the beginning of the class, let us see new announcements. Okay. Okay, here. Excuse me. So the first new announcement is May 31st, 2022. Class videos uploaded. Hello everyone. I have uploaded class videos of May 31st, 2022 to YouTube. Their URLs are this, and this. Okay. I upload the third part video on June 1st, 2022. I apologize for the delay and inconvenience. Best regards, Wei Zhen. Okay, the second new announcement is a final exam announcement. Hello everyone. According to the school calendar, June 11th to 17th, 2022 is final exam week. Our final exam takes the form of taking home. I will upload the exam questions to the eCourse 2 website on June 11th, 2022. Please send the answers to my email address comwcu@ccu.edu.tw at the latest by June 17th, 2022. Please note that this is still an exam and you are not allowed to discuss it with anyone during the answering process. Okay, best regards, Wei Zhen. Okay, next let us look at the progress of the last class. Okay, in the last class we have taught to chapter 2 slides. Page 71 MLP. Okay, that is multi-layer perceptron. And turn to handout problem 1 solution, a binary classifier. Excuse me. So everyone, please open the handout of chapter 2 and search for page 71. Okay, so page 71, problem 1. What is a perceptron? Solution. In machine learning, the perceptron is an algorithm for supervised learning of binary classifiers. A binary classifier is a function which can decide whether or not an input represented by a vector of numbers belongs to some specific class. Okay, what is a binary classifier? For example, now I give you 30 photos. Okay, and on each photo, it is a cat or a dog. So you need to see the photo, see each photo, and tell me the animal on the photo is a dog or a cat. So it is a binary classifier. It is a type of linear classifier. Okay. That is a classification algorithm that makes its predictions based on a linear predictor function. Okay, combining a set of weights with the feature vector. Okay, I think you already know what is a linear function. Okay, it is a very easy concept. And I will introduce what is the feature vector later because it is a very important concept in machine learning. Okay, next let us see the history of a perceptron. Okay, in my opinion, knowing the history of a technology is important but also interesting. Okay. The perceptron algorithm was invented in 1958 at the Cornell Aeronautical Laboratory by Frank Rosenblatt. Okay, I will introduce who is Frank Rosenblatt later. Okay, because he is a very important person in deep learning. Founded by the United States Office of Naval Research. Okay, the perceptron was intended to be a machine rather than a program. And while its first implementation was in software for the IBM 704, it was subsequently implemented in custom-built hardware as the Mark I perceptron. Okay, please see figure 35. Okay, let us go to figure 35. Okay. So figure 35 is shows the Mark I perceptron machine. Okay, you can see here. Okay, it's the Mark I perceptron machine. Okay, but this photo is not clear. Okay, by the way, if you have seen the movies, I forget, it is Iron Man or Iron Man 2. Okay, in the movies, okay, maybe Iron Man 2 or Iron Man 3. Okay, so anyway, so in the Iron Man 2 or Iron Man 3, the iron suit, the Tony Stark, he created many iron suits. Okay, and the name of his iron suits are Mark I, Mark II, etc. Okay, the first implementation of the perceptron algorithm. It was connected to a camera with 20 × 20 cadmium sulfide. Okay, I will explain what is cadmium sulfide later. Photocells. Okay, I will explain what is a photocell later. To make a 400 pixel image. The main visible feature is a patch panel that sets different combinations of input features. To the right, arrays of potentiometers that implemented the adaptive weights. Okay, so this picture or this photo. Okay, if you can see, here is the Mark I perceptron. Okay, let me show you a more clear photo on the internet. Let me see. Okay, this. Okay. So this is another photo of the Mark I perceptron. Okay, I think you now can see the words on this. Okay. So let us go back to the handout. Okay, so you can see when we open this door. Okay, open this door. That is when we open this door. Okay, we can see many wires here. Okay, many wires. So what are these wires? Okay, it is the main visible feature is a patch panel that set different combinations of input features. Okay, here. And to the right, okay, this region, or you can see this region to the right. So arrays of potentiometers that implemented the adaptive weights. Okay, like this. Okay, so let us go back to the place which figure 35 appears. Okay, here. This machine was designed for image recognition. Okay, it had an array of 400 photo cells randomly connected to the neurons. Okay, so you can see many wires in figure 35. Okay, weights were encoded in potentiometers, and weight updates during learning were performed by electric motors. In a 1958 press conference organized by the U.S. Navy, okay, Rosenblatt made statements about the perceptron that caused a heated controversy. Okay, I will introduce what is controversy later. Among the fledgling, okay, I will introduce what is fledgling later. AI community. Okay, I know you know what is AI. It means artificial intelligence. Based on Rosenblatt's statements, the New York Times reported the perceptron to be the embryo of an electronic computer that the Navy expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. So you can see that this sentence indicates an AI robot. Okay, that is if we speak in Chinese. Okay, 这句话呢说的就是一个人工智慧的机器人。Okay, although the perceptron initially seemed promising, it was quickly proved that perceptrons could not be trained to recognize many classes of patterns. This caused the field of neural network research to stagnate. Okay, I will introduce what is the meaning of the word stagnate later. For many years, before it was recognized that a feed-forward neural network. Okay, I will introduce what is a feed-forward neural network later. Okay, it is a very important concept in deep learning with two or more layers, also called a multi-layer perceptron. Okay, it is the terminology we are going to introduce. MLP, okay, had greater processing power than perceptrons with one layer, also called a single-layer perceptron. Okay, single-layer perceptrons are only capable of learning linearly separable patterns. For a classification task with some step activation function, a single node will have a single line dividing the data points, forming the patterns. Okay, more nodes can create more dividing lines, but those lines must somehow be combined to form more complex classifications. A second layer of perceptrons or even linear nodes are sufficient to solve a lot of otherwise non-separable problems. Okay, in 1969, a famous book entitled Septrons by Marvin Minsky. Okay, I will introduce who is Marvin Minsky later. Okay, because he is a very, very important person in AI. Okay, and Samuel Papert showed that it was impossible for these classes of network to learn an XOR function. It is often believed incorrectly that they also conjectured that a similar result would hold for a multi-layer perceptron network. Okay. However, this is not true, as both Minsky and Papert already knew that multi-layer perceptrons, okay, that is MLP, were capable of producing an XOR function. Okay. Nevertheless, the often miscited Minsky-Papert text caused a significant decline in interest and funding of neural network research. It took 10 more years until neural network research experienced a resurgence. Okay, I will introduce what is a resurgence later. In the 1980s. Okay, this text was reprinted in 1987 as Perceptrons Expanded Edition, where some errors in the original text are shown and corrected. Okay, the kernel perceptron algorithm. Okay, I will introduce what is kernel perceptron. Okay, later. If you have taken my course UAV communications, okay, in the previous semester, I have introduced the concept of kernel. Okay, in that case, okay, kernel is also a very important concept in deep learning. Okay, so if you have taken the course UAV communications, then when I introduce kernel perceptron in the future, you can treat it as a review. Okay. So the kernel perceptron algorithm was already introduced in 1964 by Eiserman et al. Okay. So margin bounds guarantees were given for the perceptron algorithm in the general non-separable case, first by Freund and Shapiro, okay, in 1998, and more recently by Mori and Rostamizadeh in 2013. Okay. Who extend previous results and give new L1 bounds? Okay. So what are L1 bounds? Okay, I think you do not need to know it now. Okay. However, if you still want to know what is L1 bounds, okay, you can write an email to ask me and I will answer you. Okay, next, the perceptron is a simplified model of a biological neuron. Okay, I will introduce what is a neuron later. It is a very fundamental concept in neural network and deep learning. Okay. While the complexity of biological neuron models is often required to fully understand neural behavior, research suggests a perceptron-like linear model can produce some behavior seen in real neurons. Okay, next let us introduce the definition of the perceptron. Okay. In the modern sense, the perceptron is an algorithm for learning a binary classifier called a threshold function. A function that maps its input x, a real-valued vector, to an output value f of x, a single binary value. Okay, for example, if now I want to teach my computer to make the image recognition, okay, I give my computer 30 photos, and the animal on the photo is either a dog or a cat. So we know that a photo can be transformed to a real-valued vector. Okay. A photo has many pixels, and each pixel can be represented by RGB value. Okay, that is red, green, and blue. Okay, so I can scan my photo, okay, and save it as image files in my computer, and then we can write a program to transform these images into real vector. A real-valued vector. And finally, the output of the computer program should be 1 or 0. Okay. For example, 1 may be represent a dog, and 0 may represent a cat. So f of x is equal to 1 if w dot x plus b is greater than 0. And f of x is equal to 0 otherwise. Where w is a vector of real-valued weights, w dot x is the dot product. Okay, summation I is equal to 1 to m, wi times xi, where m is the number of inputs to the perceptron. Okay, and B is the bias. The bias shifts the decision boundary away from the origin and does not depend on any input value. Okay, the value of f of x 0 or 1 is used to classify x as either a positive or a negative instance. In the case of a binary classification problem, okay, if b is negative, then the weighted combination of inputs must produce a positive value greater than the absolute value of b. Okay, in order to push the classifier neuron over the 0 threshold. Okay. So for example, if b is equal to negative 5, and the weighted combination of inputs must produce a positive value greater than 5, for example 6, okay, then w dot x is equal to 6 and b is equal to negative 5. So w dot x plus b is equal to 6 minus 5 is equal to 1, which is greater than 0. Okay, so spatially the bias alters the position, though not the orientation of the decision boundary. The perceptron learning algorithm does not terminate if the learning set is not linearly separable. If the it is 25 minutes. Let us take a break.